Welcome to the Global Medical Device Podcast, where today's brightest minds in the medical device industry go to get their most useful and actionable insider knowledge direct from some of the world's leading medical device experts and companies.
Welcome back to the podcast. My name is Etienne Nichols, and I'm the host of today's episode. In today's episode, we spoke with Laura Maher on the topic of sterilization. We covered a lot of ground. We talked about things like what's the difference and pros and cons between gamma and vapor sterilization? What are some of the tools that every sterilization engineer needs in their toolbox? What are some of the new sterilization modalities that are now available? And maybe what are some of the benefits of pursuing those? We talked about a lot of other things, but let me tell a little bit about Laura. Laura is a medical device guru at Greenlight Guru. Our medical device gurus are part of what we call the Guru Edge here at Greenlight Guru. And as a medical device guru, Laura helps guide companies through the various quality and regulatory requirements and challenges that are unique to medtech companies and medical device professionals. Laura is also a self-proclaimed sterilization enthusiast. And when I asked if she wanted to talk sterilization on the podcast, she said, I could talk sterilization all day. So I hope you enjoy this episode as much as Laura enjoys this topic. Laura Maher on sterilization for medical devices. Hey, everyone, welcome back. Today, we get to talk to Laura Maher. Am I saying your last name right?
That works, yeah.
Okay, it works. Okay, good to see you. So Laura is a medical device guru here at Greenlight Guru, and I've been trying to talk to all of our gurus and get them on the podcast to just have a quick conversation about some of the things that they're interested in. Why don't you give us a little bit of your history and background and maybe how you got to Greenlight Guru?
Yeah, sure. So I have about 10 years experience in the industry. I got my BS in chemistry and started doing QC for a pharmaceutical company, and then moved to QC for a medical device company. And that's how I was able to get my foot in the door for product development and process improvement and eventually quality system management. But along the way, I like to be the one that when someone's like, oh, we need someone to figure UDI out, I'll be like, I'll do it. And then so that brings us to our topic today is, we had to have someone take over our dose audit program, and I volunteered, and it fit really well into my interest because biology is my main passion, with chemistry is kind of behind it, but it fits in really well with that area.
Yeah. Well, awesome. Very cool. And you already kind of introduced the topic. So talking about sterilization is one thing that I only know enough to be dangerous. So I was excited when I heard how much you love it. I think when we were talking in the Slack channel, you said, man, I could talk about sterilization all day. So just someone who loves sterilization is a very valuable find. So tell us a little bit about that journey towards, I don't know, even that first taking over the dose audit program. How did that go?
It went pretty well. It's just a lot of figuring out, everything was set up we used Wuxi, and just figuring out how to ship things. Why do we do 10 samples of this and 10 samples of that, and why it had to be done at a certain frequency, and just learning the basics. And then eventually I was able to talk my way into going to the Nelson conference on medical device validation seminar that covered all of microbiology, gamma, EO, other modalities, cleaning validations and all of that. And I was just like, this is amazing. I love knowing the background of why we do the things that we do. I think it just makes it a lot more interesting and helps you understand why you're doing what you're doing.
And now you've kind of come full circle, haven't you? Didn't you get to speak at something with Nelson Labs?
I did. I went to the exact same seminar and got to speak about QMS. So that was really fun because I went in 2019 and then I came back as a speaker in 2022. So
that
awesome.
Is so cool. Very cool. So let's talk about sterilization. What kinds of sterilization are there? However you want to, focus, depending on your expertise, feel free, but just what kinds of sterilization are there?
Yeah, I'll just say high level. I know the most about gamma, a little bit about EO, and I've learned some things about other modalities, but I think the main two that people think of are gamma and EO, so radiation or gas. And then there's E-beam is kind of following up on gamma radiation. And then there's a smaller amount of X-ray. And then there's some other gas modalities that I would love to get into a little bit later on. But yeah, I think when most people sterilize their products, they either know they're going to go gamma or know they're going to go EO, or they're just going to go with what their company's gone with in the past. And yeah, they both have benefits, both have drawbacks. So it just depends on your product.
Maybe before we get into the modalities, because we're kind of talking about terminally sterilized product, what about reprocessed or reusable product? And what are the differences in how that's accomplished?
I think a lot of time, well, at least for when you're selling a device sterile, a lot of times it's single use or it might be reprocessable, but the differences in sterilization are going to be different. So when you're selling a sterile device, you can do a bunch of devices all at once. They're packaged. You have to think about what can get to the device. The device is usually clean going through sterilization, whereas when you're reprocessing instruments or anything like that, it's got to be cleaned first. So there's the cleaning validation you got to get through to get all the bits and tissue off of it. And then the hospital is usually sterilizing it. And so they use different methodologies, usually like autoclaving or dry heat, chemical or like cold sterilization is what it's called. So there's just different ways to approach.
Are they sterilized to the same level or like 10 to the -6 or whatever? I don't know what the requirements are. Do you know? It's okay if you don't.
Honestly, I don't know, but I would have to say that it probably would. I think that the risk level is the same. So you'd want to make sure you're doing that 10 to the -6.
Okay. So let's talk about the single use, the terminally sterilized product and the different types of sterilization. So you mentioned gammas. That's what you've worked with the most in the past. What are some of the differences between the different modalities?
Gamma's radiation and EO is gas. Obviously, I don't know.
No. It's not always obvious, but yeah.
But gamma is, you can do a lot of products at once. They can be in boxes. It's bioburden dependent, where EO is a little bit less so, but your dose is 100% dependent on what your bioburden is. It's cheap usually to validate. Keeping up with dose audits can be a cost consideration depending on how many product families you have. But usually, at least like the validation and getting going with it is cheaper. But it is kind of harsh. You can't sterilize batteries with, there are certain polymers that can't stand up to it. Silicone adhesives can't be gamma sterilized, but a little bit different. And then EO it's got excellent penetration. It's a small reactive molecule. It's got good compatibility with a lot of different things. So that was why we went into EO, as we incorporated silicone, and silicone can't be gamma irradiated, went to EO, but it's got the same benefits of you can sterilize whole pallets. It's high volume, but some of its cons, you can't EO sterilize batteries. The cycles are really long. It requires vacuum. So that changes how you can package. It's also explosive and carcinogenic, which is, not ideal.
Yeah.
Working around it.
Yeah, EO has a sordid history, I guess. And let's go back to gamma for just a moment, just to kind of clarify. So when you say you can't sterilize silicone with it, is it because it stiffens it, or is there a requirement against not doing that, or is it just because of the effects?
The ionizing radiation changes the structure of the molecules, and then they no longer function the way that they should. So that's why plastics get more brittle, and like the silicone, the stickiness kind of just goes away with that. So it changes it too much. And then I had another point going back to that. Well, if I remember.
Yeah, man, this is like reaching back into the recesses of my mind of material science. I think it's the vulcanization process, right? The cross-linking. Yeah. Okay.
Cross-linking, that's the word. Yeah, cross-linking. It causes cross-linking and changes the structure and the properties of materials. It also discolors things. But for plastics, it's staying up to it. If you put blue dye in your plastic, it won't turn yellow, which is what it is.
Interesting.
I can smell, like our products, I could smell them and tell if they've been sterilized because it creates ozone, and ozone has a smell to it.
Oh, yeah. Wow. It's H3O. Interesting. But I don't think H3O, that's not right.
It's O3 maybe? I should know that. I'm a chemist, but
I shouldn't get on here and start spouting off molecule names if I haven't got it in front of me. I'm actually going to look it up though now.
That's okay. I was talking about EO one day and I said ETOH. I'm like, that's not the same thing.
So what are the other ones that you said? You said EO has kind of some negative sides to it, but it also has a lot of positive to it. Maybe what would be interesting is the actual validation of each one of those. So if you go through the gamma, walk me through the process of what that even looks like to actually validate that process.
Yeah. So that involves, I apologize, like the step-by-step is a little bit fuzzy. I'm trying to remember back, but it's very bioburden based. So you want to look at the bioburden for different lots. It's usually done over 3 lots. You look at bioburden for, do VD max. So the sample sizes are VD max 25. So like 10 samples of bioburden, you do sterility samples. So you want to make sure that there's nothing in your device that's inhibiting the growth, or that's bacteriostasis, fungostasis. Sorry, that's a part of it. But you want to make sure that there's nothing in your device that's inhibiting the growth of bacteria. If there is, you'll get a correction factor applied to your bioburden count. So we had silver in our devices, and so they would do something to deactivate the silver, but also there was a correction factor to multiply up our level of bioburden to account for any death that happened because of the device. And then you have sterility, where you take sterile samples of your device and it's dosed at a calculated verification dose. So you're aiming for 10 to the -6 of sterility, which is a 1 in 1 million chance of a non-sterile device. And so the way that VD Max works, and I think it's really cool, is your verification dose, you're aiming for 10 to the -1. So then there's a 1 in 10 chance that your device has bacteria on it. So that's why we do 10 samples and you can have one failure. But you do those sterility samples, you do that over 3 lots, and then that's considered validated. And then you have your quarterly dose audits, which you are testing usually a master product or different types of product from a family every 3 months to make sure that they're, not having too much bioburden for the dose, and that you're not having, the sterility tells you if you have like resistant organisms as well.
Okay. So the first step is that 3 lots that go through, and then you're going to have a quarterly audit after that.
Yes.
Okay. That makes sense. So that's for the gamma. Go ahead.
There's one pitfall to avoid is that we call them quarterly dose audits, but the requirement is actually every 3 months. So if you're doing it in January, doing it at the end of Q2 in June, or is it June? Yeah, is not kosher. So you have to make sure that you're pulling every 3 months and planning that ahead of time. Planning is especially important, but that having backup lots, at least for us, sometimes materials didn't get pulled. And so you made sure you had a backup lot where that extra material was made that we could pull for those audits.
And for the dose audit, what is the sample size that you may have mentioned already?
It's 20, but I always included a couple extra in case something happened. You want to include extras in case there's some laboratory error, and you need to like retest something or check something out. So it was 10 bioburden, 10 sterility.
Okay, very cool. And what's the difference when it comes to EO, or do you know the differences in those validations?
So yeah, EO is not bioburden based. It's done based on like bacterial indicators. So they use a really resistant bug. I can't remember the bug, but they use these biological indicators. And so
is it like a staph or something? Or when you say bug, or?
It's like it's some like really, it's like not something that would normally happen, but it's just really resistant to. So that it's kind of it's called the overkill method, or at least the one that I know about, where if it can kill a certain amount of this really resistant bug, then anything else is covered. And then there's also like the half cycle method that goes on. It's a very more complicated process.
Okay. No, that's fine. But yeah. Okay.
So the half cycle is like they do the half amount of cycle that you would do normally, and they kill a certain amount. I think they have to reach 10 to the -6 or something close to that. And then, if the half cycle kills that much, then the whole cycle is going to be more than adequate for anything you ship through there. And then it's only done on parametric release. So there's no dose audits. There's no additional testing that you have to do. I don't think it's a bad idea to do some sort of regular bioburden testing on your product just to keep up with that trend in your process and making sure you're cleaning well. But other than that, it's a lot less maintenance. So more cost on the front end, less cost maintenance, where gamma is cheaper on the front end, but more cost in the maintenance.
And what does it mean, a parametric release?
So the parameters of the cycle, if they meet the validated, if you're hitting all of the parameters that were validated, it's considered good and you can release it. Well, gamma is also, I don't know if it's technically parametric release, but you're going based off dose. If it has that dose, then it's good. But you're doing the dose audits, every couple of months to make sure that you're meeting sterility requirements.
So in your mind, when you think about, I don't know, gas versus radiation, you already talked a little bit about, silicone and the effects that it has on it. So if you do have a silicone product, you have to consider that and engineer it into that. And so gas versus radiation, are there thoughts in your mind when you'd say, well, obviously, you already talked about silicone, but just some things like, I would not use this modality for this type of material versus that. Anything's popping in your mind or advice you would give when it comes to choosing these different types of sterilization?
Amy actually has a TIR that talks about material compatibilities with different sterilization modalities, and even like from a scale. So where something could be like very compatible with gamma or very compatible with EO, it could be, mostly compatible depending on how you're using it. And it gives you a scale so you can look at all the materials in your device and choose the best modality. I prefer gamma. I like the science behind it, and I think it's more interesting, but I don't know, it's really up to your device and what's close by and how many suppliers are available to you and what the cost looks like. So
yeah, that makes total sense. So we'll try to put that link in the show notes. I need to put a note to myself on that to make sure we get that. So the Amy TIR. You also mentioned some up and coming modalities. What are some of those that are available?
So I think some cool ones there's like peracetic acid and hydrogen peroxide vapor. A lot of these have some limitations, but one thing that was really cool that you kind of turned me on to was chlorine dioxide. And I started looking into that, and I'm like just very impressed with the science that goes behind it and how easily it can be transitioned. If you go from EO to this chlorine dioxide, it's safer. It can be done in boxes. So that, like the other types of sterilization, your items can't be boxed and palletized, which I think saves tons of time if you're high volume product. So yeah, that seems pretty cool. And it can be validated the same as EO. I didn't know if you knew that.
No, I didn't know this. Let's dig into that just a little bit more. So the boxing versus not boxing for gamma or EO, how much do you have to strip it down for the sterilization to work?
So EO is pallets. Pallets just go straight through the chambers. The pallets do have to be broken down for gamma to be put into the carriers that go through the chamber, but you don't have to break it down further than the pallet. The pallet gets broken down, boxes get stacked up with dunnage, whatever they need to make sure the dose mapping is correct, and then they get put repalletized. Whereas some modality and e-beam it's on a conveyor, but it's box wise. But from what I understand, like peracetic acid and all that, they can't be boxed. There can't be a lot of barriers for penetrate because they're not gas, they're vapors. So penetrating all of those layers of packaging is a challenge, whereas gas can do that.
Same with hydrogen peroxide is a vapor. Okay.
Yeah.
Okay, that makes sense. And so the chlorine dioxide, then you could have that in-house then with your, if you wanted to buy the materials to do that or the equipment to do that, you could bring that in-house. Whereas like as opposed to EO, that would likely not be considered a possibility.
I think some like hospitals sometimes have EO sterilizers, but a safety risk, you have to have scrubbers, whereas like chlorine dioxide doesn't create anything that can't go into the environment on its own, or it can be scrubbed very easily with carbon versus EO. Not good for the environment, needs to be scrubbed. Its residuals are not safe for individuals. So yeah, I would say that chlorine dioxide, from what I've read, would be much safer to have in-house.
Okay.
Sure.
Very
and then
cool.
one thing I thought was interesting is EO, if it's exposed to air, can explode, which is problematic, as you could probably imagine. But chlorine dioxide does not. So you don't have to pull the vacuums with the cycles like you do for EO, because you got to pull the vacuum, flush with nitrogen, pull the vacuum, do the EO.
Yeah. So it's funny. One of the things that we talked about early on was like reprocessing versus the terminally sterilized single-use products. And you're probably right. I don't know the level of sterilization or the difference, but I remember having to go through a validation, or I guess it was a validation where we performed the World Health Organization requirement level for autoclaving a certain product. So I remember we were trying to get that thing done. So I spent nights with the autoclave waiting for it to finish. We'd watch movies while we waited for it to finish. Then we'd run over and scrub it off and put it in for the next cycle with all the bleach. In my mind, when I think about the EO potentially exploding, something that you can have in-house and just run makes a lot of sense. That's interesting. So what are some of the tools of the trade? When you went through this, they sort of just threw you into the dose audit. And we've talked about this before, how you're just sort of the figure it out person, which I really admire about you. What are some of the tools of trade that help you get through that time?
So I bought all of the AAMI standards around sterilization in general. Like we had it was like a hefty book, and I wish I could have kept it, but I steal from my company, sadly. But it covers like everything, like the microbiology side, EO, gamma, all of the TIRs. The TIR, I think it's 33, is like what it talks about adopting products into your dose audit families, which was particularly helpful. It came out kind of around the time that we were developing new products, and I had to figure out how we adopted them into families. And I was like, this is perfect. It tells you exactly how to do it and what's acceptable and what's not. So I love those standards. They're helpful. A lot of like Nelson, Steris, a lot of companies have a lot of great resources online available to you for free, blogs and white papers and a lot of things. And everybody I've met from any sterilization company or that's involved in that, they're very passionate about what they do, and they love to talk to people about it. So you can always kind of build up relationships with the people, the sterilizers that you work with, or if you're able to go to conferences like that Nelson one, people will talk your ear off about sterility all day, which is super fun. But my favorite thing to get from that Nelson seminar is I have these slide rules, which this one's like biocomp and reusable cleaning validation, but they have one for EO and for packaging testing. And it's super fun because it tells you like you have patient contact, duration, and you slide it and it tells you what tests you need to do and what needs to be done. And I think that's just super fabulous when you're day-to-day working. You can just pull out it and figure out what you need to do.
That is fantastic. I had never seen one until you pulled one of those out the other day and showed me that. That's very cool. I'm going to have to find a link to, well, I'll link to Nelson Labs for sure, but I'll also link to the presentation you gave to Nelson Labs so people can hear more about that. But maybe there's some way to get a slide rule. I don't know. Did you get that to the seminar or how do you get that?
Yeah, that's actually the one, like whenever they're like, oh, do you want to go to Nelson? I was like, I can get new slide rules.
Very cool. Oh, wow. Any other good stories? One question I might have is, what do you do when you have dose audit failure?
So it just involves a lot of investigation. You can retest or do some additional testing of product. And I'm blanking on what the number of samples is, but there's like a certain number of samples that you can retest. And if they pass, I think it might be 10 more. And as long as you don't get additional failures, and it's like 20 and 1 out of 20 still meets that 10 to the negative 1, or 2 out of 20, it's 2 out of 20 still meets that 10 to the negative 6, like your dose audit process, sorry. So you do that, but also what a lot of people don't realize is your bioburden. If your bioburden starts trending up, or if you get a too numerous to count plate or something like that, where you're not failing your dose audit, but there's something wonky going on, you need to investigate that and we're audited by BSI for a micro program. They'll want to make sure that you're looking into that kind of things. We had one case where we had a too numerous to count plate. The ID came back with a fungus that is primarily almost exclusively found in wood. And our product is like fully synthetic packaging. No part of our process should it be contacting wood. And we were just like, what? Like just how? So we were just swabbing everything we could think of. And then one day I was walking on the floor and there's just like chips of pallet wood. And I was like, maybe that was it. We never found out where it came from because we swabbed pallet wood and didn't get anything off of that. So I don't know.
Wow.
It's just a great mystery, but we did investigate it and we did make sure to monitor that wasn't a repeat organism. But yeah, a lot of times your test lab will tell you if you get a too numerous to count plate and they'll ask if you want to ID the predominant microbe. It's money, but I would say yes, it's a good idea to know because it could be something that's sterilization resistant and you just want to keep track of that. And then trending too, you have to have alert and action levels when it comes to your bioburden. So making sure you're trending that so that your action level is going to be pretty much set based on your sterilization modality, at least for gamma, but your alert level is going to be based on your trending. So,
okay. So the too numerous count, it's just the plate. Tell me a little bit more about how they do that, if you could.
Yeah. So the plates usually depends on how they're plating, but some of them, if they're filtering, will have a grid pattern and they count, the number of colonies on there. Too numerous to count is when you have, as a microbiologist once called it, a lawn where it's just covered in colonies and there's no way to distinguish colonies from another colony. And you got a lot of bacteria there, basically.
I see. And then they're willing to identify the most prevalent one, I guess.
Yeah.
Okay. Someone was telling me about this where they were having an issue with their anodization. Yeah. So in their anodization process, they were having an issue. It was streaking or something like that. So it's not really the same. It's not sterility or anything like that. But going back to go ahead and ask what the thing is, they went into, I think they used a spectrometer to determine what it was with the anodization that might be different because there didn't seem to be no issue with the process. And they were finding something that was biomatter or organic. And so they went up the train and they went to the actual anodization place, the anodizer. And the only difference was one was like the good anodization stuff was coming through in one shift and the other was on another shift. So they couldn't figure out the problem. They were doing exactly the same process. And they realized one was bringing their cat to work and the cat was going in the anodized material, so upstream and literally. So anyway, that made me think of like the CAP or the investigation. It's worth going upstream, even if you can't figure out what it is exactly in your case with the wood. That's really funny.
A lot of times that, knowing if it's bacteria, you have a good idea where it came from, or even like with some of the fungi, because the type of bacteria will tell you if it came from your process or like water or human. So microbiologists, don't kill me if I get this wrong, but I'm pretty sure the gram-negative bacteria come from water. So if it's like Pseudomonas or something like that, that's popping up, then, your water system might have issues. There might be some sort of contamination in the process. If it's gram-negative, then it's human, or gram-positive, then it's human. So like the staph bugs and Enterococcus, like things like that, if those show up, then you know that people are not using their PPE correctly or they're touching the product.
Interesting. That's really cool that they have a way of determining that. I could definitely see how that would help with your determining what we're doing. So what are some sterility pitfalls that you've maybe experienced or maybe heard other customers experiencing that they could overcome?
Oh, so I have many. Having to learn the process or on my own, or like having to figure it out. You find mistakes, you make mistakes. So I think something that's important to consider is that sterility is not just how you sterilize your product. Packaging is like a huge component of sterility because it's your sterile barrier. It's how it stays sterile and how it stays sterile for years or however long. So you need to make sure you're doing packaging validations, doing packaging testing, doing aging testing on your packaging. So we actually had a packaging failure. We were using a poly pouch, and just with the size of the product and everything, after 5 years of accelerated aging, it started cracking, and the seams are like the wrinkles. And obviously you lose your sterility at that point. So do aging, accelerated, and real time. You have to do real time. I think another pitfall is not keeping up with the requirements. So not doing your dose audits, not testing bioburden.
Or doing it quarterly instead of every 3 months.
Or, it's okay to miss a dose audit if you don't make product. But if your poor planning is why you didn't get product to test, that's completely different story. So making sure you're staying on top of that, not trending your bioburden and not testing when you have issues come up or it starts trending up, because you're showing that you're not. First of all, when it starts trending, you're out of control. Like it's showing a loss of control in your process. And also you're not trying to find out why that's happening. And then I think a good thing I learned from Nelson is that if you have like one spike in your trend, that's not a fluke. That's a rare and random issue in your process. So like, even if it's just happening once, it's not like, oh, okay, well, it just happened once, it's fine. You need to try to figure out what's happening or why that's happening. I think the biggest one that people don't think about is you need to control bioburden before you sterilize. A lot of people are like, oh, it's sterile. Who cares if I wear gloves, or who cares if we do this? I'll ask if you know this. Do you know what happens or what is an issue when you have too many dead bacteria on your products?
I don't know.
So bacterial endotoxin, medical devices, almost all of them have some sort of limit on the amount of endotoxin. And then other devices that go into like cerebral spinal areas or like dialysate liquids have a very low limit for endotoxin. So if there's too much bacteria on the front end and you kill it, you're creating a high number of bacterial endotoxins.
Interesting. I knew we always tested for endotoxin, but I didn't know what that meant. So that's the bacteria you killed up front.
Yeah. And those toxins they're pyrogenic. So they can cause fever and illness in patients. So definitely not something you want on your product. And then once it's in your product, you can't really remove it. So there may be a process, but not easily without having to, go through things. But yeah, bioburden control on the front end, having clean water, having a good water system and maintaining that water set. Water systems are like a whole nother thing I could go into of keeping water systems clean and keeping up with that too. Also, bioburden is important to control for like gamma considerations. If you have a really high level of bioburden on your product, that's a higher gamma dose that you have to have, and that's more damage to your product. And it creates problems. So the lower amount of bioburden, the lower dose you can have, the wider window you can have as far as like you have like the minimum dose to reach your sterility level, and then you test yourself a maximum dose of figuring out what your product can handle. And so if your product can handle, 40 kilogray, but you can go with 25 kilogray or lower, then that's a huge window to allow for augmentation if, something happens in the process or you have a failure or something like that. So it's always good.
That's really helpful to understand how each one of those processes connect to each other or sort of flow into each other. Clean water. Yeah, that's good advice. You got me curious, though. You said you could go on about water systems. So what are some of the things that you experience with that as it pertains to this subject, if possible?
So many things. So one of the medical device company that I worked for that I was doing QC was a dialysate concentrate manufacturer. And so I learned a lot about maintaining water systems, and we had a very strict amount of like certain chemicals that could be in the water, endotoxin, bacteria. So we tested the water weekly, and if we were exceeding our levels for endotoxin or bioburden or anything, it was like instant shutdown. No production can happen, have to empty out the tanks, do several clean in place cycles with a cold sterilant, and then test it again. And so keeping good water quality was essential to manufacturing because everything is a liquid. And then in another industry that used water And the water system, it was our water system in place, but it didn't have all of the parts that it needed. There were lots of long, skinny pipes with dead legs, which is kind of like where they bend like that, or dead ends, which are very easy for bacteria to get in those places and start building biofilm, which is like a big polysaccharide goo that makes it very hard to remove them. And they just have fun growing and getting all over everything and causing issues in your water process. So yeah, it's just good to be mindful about how you input your or make your water systems, that they're easy to access, easy to clean. You're bringing in not dirty water in the first place. So you want to go through some sort of filtration before you go to your RO system, because it's not, RO systems are great, but they're, I don't know, this is kind of a weird way to say it, but they're only human. Like, you've got to give it good water to get good quality water on the back end.
That makes sense. I should have known when I was talking to a chemist that I would hear the word polysaccharide. And you are 100% right as far as like ozone. I was completely wrong on that. So I felt like I should clear that up. Looked it up.
Well, we used ozone to kind of clean the air at the dialysate manufacturing route, so that we had dry product and wet product. And we used the ozone in the dry product room. So that's how I knew how it smelled. But also, I was very curious about it at one point to figure out why it was like that, and if it was safe to breathe all the time. I had a lot of questions.
That's interesting. Okay. Any last comments, recommendations that you'd give to companies that might be looking to, maybe they don't have actually one question we didn't answer is, what if you're going from one to another? Do you have any advice or recommendations when it comes from going from one sterilization process to another?
Mostly just work with a company that knows what they're doing. So your sterilizer, your lab, whatever you're using, they can help you through that process and make sure that you're not missing anything. And they'll give good recommendations for what you need. But it's always good. So if you're going from like gamma to EO, bring over your bioburden data. And, that helps when they're trying to figure out where to put you in a cycle, because they try to group with gamma and with EO, they try to group similar products that have the same parameters together, or fit you in with a cycle that already exists. So bringing in data on either side will help them kind of figure out where you fit in. And you'll obviously be doing testing to help kind of support whatever dose that you're going to be at and whatever cycle you're going to be in. So,
and check out carbon dioxide, I guess.
Yeah, check out the new modalities, because I saw there was one, I don't know how many do that. Is it chlorine dioxide gas? But they are FDA certified, I think, to sterilize. So even though it's pretty novel, with it fitting in with, like, they have similar validations to EO, and that the FDA has already kind of given them the green stamp to sterilize medical devices, it makes it a lot easier to check to move into a newer modality when they've got all that set up already. Another thing, if you have the chance to see a gamma source, take it. It is really cool. I had that opportunity when I was doing our yearly audit of our sterilizer. I told them when I got there, I was like, if the source goes down, which means like they have a water tank that it stored into, not gamma irradiate humans that go into the chamber. I was like, if the gamma source goes down, I want to see it. And they're like, you've got it. And we're getting towards the end of the day and like watching the clock. And I'm like, oh, I don't think it's going to happen. It's like 5 minutes before we're about to leave. They're like, the source is down. And like, I got to go and see it. And it's just this big rack of, they're called pencils. So like they're rods with the cobalt 60, I think it's cobalt 60 in there, but like it glows bright blue, and it's just incredible. It's really cool.
Really?
Yeah.
Huh. I'm going to have to Google this afterwards. I never thought about going that far upstream, the sterilization. Wow. Okay.
It's cool.
Bucket list.
Seen the source.
So cool. Well, Laura, thank you so much for being on the show and sharing all your experience. This has been really fun. I'll put links in the show notes. Let's see, I have a list. I think we said the Nelson Labs, your presentation, the Amy TIR reports, and I'm sure there's something else, maybe some stuff about the different modalities, but really good. Thank you so much. And for those who've been listening, you've been listening to the Global Medical Device Podcast, and we will see you all next time. Thank you so much for listening. I hope you enjoyed the episode. Just a few of the points I took away from the conversation were, number one, gamma is less upfront cost than EO, but it has more maintenance costs due to dose audit requirements, whereas EO is more cost upfront, but less cost to maintain. That said, EO has a larger environmental cost and risk associated with it, so it's something to consider. The second thing I learned was Nelson Lab conferences apparently are life-changing. And if you go, you need to make sure you get one of their sterilization slides that will tell you all the different testing requirements. I'm going to have to get me one of those. Third, there are new modalities out there, sterilization modalities that the FDA recognizes as safe and effective. One case in point is chlorine dioxide, something to be looking into. So don't be fooled by the false dichotomy of gamma versus EO. Be sure and check out the newer modalities as well for your medical device. If you enjoyed this episode, reach out to Laura on LinkedIn and let her know. Tell her you appreciated it. Also, I'd personally love to hear from you via email if you have any feedback at all, etienne.nichols@greenlight.guru, or look me up on LinkedIn. You can learn all about what we do if you head over to www.greenlight.guru. We're the only medtech specific EQMS. And on top of that, we built a community where you can go to join the conversation or learn more about the things we discuss on the podcast. You can find those at community.greenlight.guru or academy.greenlight.guru. Finally, please consider leaving us a review on iTunes. It helps others find us and it lets us know how we're doing. So thanks again. Y'all are the best.